Hello everyone, today we're focusing on the Cambridge IGCSE Mathematics topic of algebra, subtopic of simplifying algebraic expressions. So to begin with, we're looking at what does it mean when we want to simplify expressions, right? So if we're adding or subtracting, what you need to see is whether the letter or if it's the same letter, basically, if it is, then you can add it together. So 5 plus 3 is 8, like normal mathematics. If the letters are not the same, that is, if it's one X and one Y, then they're different. So we call these unlike terms. So unlike means they're not the same, basically, right? So when they are the same, you call them like terms. Now, if you look at subtraction, if the x squared, the powers are also the same, then also we call them like terms, and you can carry out the normal mathematical subtraction, and that is basically 3 minus an imaginary 1 here. So basically this is 2x squared. But if you have, for example, BC 9b, or if I take this as 2x cubed take away 3x squared, then you cannot subtract it, because again we have the situation of unlike terms. So always remember, in order to simplify, you need to have like terms only, right? So moving on, to simplify an algebraic expression, we can combine the terms. Okay, so basically, if you look at this massive expression that's given here, it's hard for us to actually simplify this. So what do? We look at grouping. So we look at the two terms which have power 3 and group it together. And when you group, it's important that you remember to take the sign in front of the coefficient. So this one, -2, you have to take that, right? And then same way, I'm going to group 3x squared and this negative x squared together, and I'm going to group 2x and this negative x together, finally leaving me with the plus 3. So you can see that after I have grouped it, I have received a simplification like this. And from there, it's basically a matter of applying normal mathematical subtraction or addition where required. So that is, if I have 1x cubed and I'm subtracting 2, that is going to be -1. If I have 3 take away 1, that is 2. If I have 2 take away 1, that is 1. And finally, the plus 3 just stays on at the end. So moving on, if we have an expression like this, x squared plus 2x plus 3 plus 2x squared minus 3x. So what you have to do is you have to simplify this, right? And what we are going to do is again group together the x squared terms, and then we group together the x terms, and finally we have the positive 3 at the end. And again we simplify this, so it becomes 3x squared negative x plus 3, right? So moving on, similar ones coming up here. So again, every time you're given an expression, think about how can we try and simplify it. So in this case, we have a negative here. And remember, when the negative is outside the bracket, that is like basically applying the negative to all 3 terms inside the bracket. So that's what's happening in the next line. So we have negative x squared plus 2x -2. And once you've got that negative applied correctly, then it's a matter of grouping again. So grouping the x squared terms leaves us with 2x squared. Grouping the x terms is basically -3x, and finally the -2 just on the end. And same thing here. So we are taking out the negative first, and then we are grouping, and then we are simplifying, right? So even if it's 2 letters, you still can add and subtract the same way as long as the 2 letters are same. So here it's both AB, so you can simplify. If one was AB and one was AC, you wouldn't have been able to. And the next thing is expanding brackets, okay? We also call this the distributive law. So when you expand brackets, basically what you're doing is you're multiplying the term that is on the outside of the bracket with every term that is on the inside of the bracket. And you must remember to take into account the signs associated with it. So for example, 2x into 3x is equal to 6x squared. Because it's x into x, it's like saying x to the power of 1 times x to the power of 1. So that is basically like saying x to the power of 2, because exponent laws say that the powers should add. And then we have 2x into y, which becomes 2xy, and -4z into 2x, which becomes -8z. So that simplifies it there. We can also apply again, like what I said earlier, if there's negatives outside, please simplify the negative. So you can see this becomes negative x plus y, and then we're simplifying. So the x terms simplify together, y terms simplify together, and I'm left with this expression here. And the most important one is this one here. When you have x minus 3 squared, this is the same as saying x minus 3 into x minus 3. So you can't just simplify by squaring the first term and by squaring the last term. When you do that, what will happen is you are going to end up missing this center term. So to ensure that you don't miss the center term, you have to remember that any bracket squared has to be written as the bracket multiplied by itself, and then you have to go about carrying a expansion step by step. And in this expansion, what you can see is, so basically every letter in the first bracket has to multiply both the numbers in the second bracket, right? So this x is multiplying the whole expression in the second bracket. Same way, this negative 3 is multiplying the whole expression in the second bracket, and that's how we're getting all these terms coming in. X squared take away 3x, take away 3x plus 9, which then becomes x squared take away 6x plus 9. So the next thing here we can see is smaller expansions like this. So when you have ab into 2ab, remember that a is into a, right? So there are two a's coming there, which is x squared, a squared. Then there are two b's coming there, which is why we get b squared. Same way, there is 3ab, so that is coming as 3ab here, right? So again, another expanding the bracket one. Remember, you have to multiply this x by this x, which gives x squared. This x multiplies by 2, which gives the 2x here. Same way, this 1 multiplies the x here to give x, and this 1 multiplies the 2 here to give 2. So finally, once you have got all four terms, you can add the two middle terms together to simplify further, which is what has been done here. And this is one of the most important things you will need to do in algebra. When you come to dividing expressions, okay, so what you can ideally do is try and figure out if there are factors that are common. So you can see that here in the denominator, you can pull out a common factor 2 and a common factor x out. That is what's happened. So I'm taking out 2x, and then that it becomes 2x into x plus 2. And then I can cancel off the 2 in the numerator, the 2 in the denominator. There's an x squared in the numerator, which I can cancel off with one of the x's, leaving me with one x in the numerator along with this x plus 2. So it's all about simplifying bits and pieces, right? And when you have expressions like this in the numerator, you have to see whether you can factorize. Now don't worry about factorization much. We're going to have a separate video on factorization. But when you are able to factorize, if you can find a common factor bracket, then you can cancel those brackets down. That's what's shown here. And in terms of indices, so we're going to look at indices. Now remember, 5 squared basically means 5 into 5, which is 25, right? So we call this 5 squared part the index form, the 5 into the 5 part as the expanded form, and we have the 25, which we call as the numerical form. So these are all just notations and words that you have to be aware of. So these are the basic indices rules that you should know. So when you're multiplying two things where the base is the same, so that is both have to be letter A, but the powers are different, m and n. If you are multiplying, then the powers will add. If you are dividing, the powers will subtract. That is shown by the examples on the right hand side. So when I'm multiplying, the 4 plus 2 gives me a 6 power here. When I'm dividing, the 9 minus 3 gives me the power 6 here. So it's very important to see the difference in powers there. And moving on, the next rule is a to the m to the power of n. So when you have something to the power and you're powering that again, the powers will multiply. So for example, when you have 4 squared to the power of 5, the powers multiply, resulting in 4 to the power of 10. Similarly, a to the power of negative m, you can basically write as 1 over a to the power of m by taking the negative at the bottom. And This means that 9 to the power of negative 3 is the same as 1 over 9 to the power of positive 3. You also should remember that if you have a to the power of m, then this also can be taken down and put as 1 over a to the power of negative m. So just remember that the sign flips when you take it in the denominator. The next rule is basically square roots. So if you have a to the power of 1 over m, that's basically saying m root of a. So for example, 16 to the power of half is basically saying the same as 2 root of 16, which is 4, sorry. Then if you have a to the power of m over n, that is the same as saying root of a, and that goes to the power of m, right? So basically, alright, so we're going to finish off with some questions. So x plus 5 squared. So remember that this is the same as saying x plus 5 into x plus 5. So this then becomes x squared plus 5x plus 5x plus 25. So this becomes x squared plus 10x plus 25. Right? So therefore, looking at the options, this is option number 4. Then next one, so I can remember we have to group the like terms. So I'm going to group the 2x and the negative 2x together, and I'm going to group the 7 and negative 7y and negative 3y also together. I should ideally put a plus here so that it will make sense. Okay, and this is going to be 0 plus this is going to be negative 10y. So the answer is again option number 4. And moving on, negative 4a, and then this expands to plus 4b, negative 2a plus 2b simplifies to negative 6a plus 6b, and this can be further simplified if we pull out the 6. So this is negative a plus b, which is option number 3.
Subscribe us now for more videos and content.